Okay, right now we should continue the discussion of the three great circles, making a big deal out of it because it is. If you understand this, you're good to go from Perikid Zayin till the end. Because everything evolves around these three circles: celestial equator, ecliptic, horizon. So, Baruch Hashem, I have here a model. I hope it. Let me take it apart, and hopefully this will help out the situation here. So this thing here is in the middle. You can see the blue ball. That's Earth, and this ring is the ecliptic ring. It has a picture of the Mazalas on it. Then we have the center ring is the celestial equator. Forget about all other rings now. It's not important. The other rings, some of them are not even great circles, and we're not discussing them now. So again, just focus on the wide one, that's the celestial equator, and the center, the wide one is this one here is the ecliptic, and this one here, the thin one, is the celestial equator. Hope the camera shows it well. So you see the ecliptic is not right now. You're seeing the part that is north, the mazalas that are north of the celestial equator. That's from Taleh till Miznaim. And you can see this line here, that's part of the celestial equator. I'll give you the other side. You see separately. Here is the other side. So it's like this. From here to here are the mazalas that are from Miznaim till Taleh. And these are beneath the celestial equator. The celestial equator is here. This ring here. Okay. So you got the two sides of the thing. This is like a small celestial globe. So I thought this would be better. This is the top of the ecliptic that's above, and the other one is below. Now, this thing here is called the horizon ring. This horizon ring is meant that you should take this thing and put it in the horizon and show which part of this is visible for a given latitude. New York, Eretz Israel. So what you do is like this. You have to insert. This has two slots. You insert it. Now take a look. This point here is the North Celestial Pole. And as we showed last year, this is for Eretz Israel, it's 32 degrees above the northern horizon. For us, it's 40. This is set for Eretz Israel, 32. Take a look at this side and try to see, try to focus not on the ecliptic, but rather on the celestial equator. I'm following it with my finger. You can't see it from the other side, but at least this side you can see it. I'm going to follow it again with my fingers to be able to see it. No. Here we go. You see? This is the point where my finger is here. Let me use the pen. This point is where the celestial equator touches the horizon. And it goes up and continue. Now here it meets the ecliptic. And as we said previous year, I know it's not so easy to see on the screen, but I'm trying my best here. So the celestial equator is meant to be always at an angle of 58 degrees. I'm just turning now now try to see something interesting. The celestial equator always is the same angle. If you keep looking at the screen, you see the ecliptic keeps on changing its angle towards the horizon. That's, if this itself, the whole video was worth to get this point. The celestial equator is always the same. It's always 58. Now, we're going to take two things that we're going to, once we know this, we'll understand a lot of things later in the Rambam. Oirech Revi and Shinui Mara. We'll take 2 points. I'll go back to the Sefer now. 2 points. Okay, so we start like this. First of all, before we get to look at this chart, how this works, we'll take a look at the So this, let's take a look at this picture. We showed it last time. It's a very important picture. So this here is the this here is the celestial equator. This point here is south, and this is from the horizon. This rubber band here is the horizon. The horizon. From the horizon till here in Eretz Yisrael is 58 degrees. This angle here is 58. Because this is tilted 58 degrees from this. Next. This rubber band here represents the ecliptic, and this is the celestial equator. So we know the angle from the ecliptic towards the celestial equator is 23.5. This angle is 23.5. Now, let's imagine that I'm telling you how much degrees of the celestial equator has. Let's say this is called 0 degrees, because this is where it meets Tele with celestial equator. Let's say I tell you this is 30. That means 2 hours after 2 hours after 0 was on the horizon. So 30 is now on the horizon. That's exactly because I said last video. Each degree takes 4 minutes. 30 degrees, 120 minutes. Now the $1 million question. How many degrees is this? How many, when 30 degrees of the celestial equator is on the horizon, what degree of the ecliptic is on the horizon? Please understand very well that this goes in a uniform. However, the ecliptic fluctuates back and forth. It's not always the same. This is very, very fundamental. This is Eirich Shlishi, Eirich Revi, everything around this. Another question, what is the inclination of this angle here? That means the ecliptic towards the horizon. So that's this angle here, and I'm showing with my cursor now. And mathematically, if you know the formulas, you can solve both with very similar solutions. So again, the triangle that was created is, which triangle? We know this big angle here, 23.5. We know this big angle is 58. Why? Because this is the inclination of the horizon towards the celestial equator. So we know two big angles. We know also we're given that this is 30 degrees. It means 2 hours after 0. Now the two questions, most important. What is this angle here? That's the opposite of this. So if you call, let's say, this A and this B, so this will be called small b. That would be how many degrees of the ecliptic has set. The second question is, what is this angle? Or actually it's this angle, but it's the supplement of this. So that will be whatever. If you find out this, we automatically know 180 minus that will be this. And that is called the Netiyas HaMilke. How many degrees is the ecliptic inclined towards the horizon? These two questions are going to be dealt, and I'm going to show one more, then I'm going to finish the video. This shows actually what happens on Tishrei. Not on Tishrei, I'm sorry, when we have the part of the ecliptic that's 180, 2 hours after setting. I gotta plug it in, so I'm sorry for that. Okay, so this shows, again, we solve this triangle, but let me just go through some different stuff. We know we're giving you, this is, again, remember, the triangle is a little bit different here, because this is right now the celestial equator. Again, we say that celestial equator has set from 180, this area, from 180 till, let's say, 210. This part is set. This 30 degrees, 2 hours after 180 was touching the horizon. We know this is 23.5. We also know the horizon towards this angle here is 180 minus 58. This y angle. We need to find this. And also this part. How much is this inclined towards the horizon. So this is the two formulas. This is two extreme cases. Here you can see this angle is much more. It means to say that when we got the 30 degrees from 180 to 210 setting, we have a bigger part of the ecliptic that's set during that 2 hours. Masha Inkain, when we got from 0 to 30, then much a lesser part of the ecliptic set. And that's why we need to have a certain chart, and we work out with formulas exactly each degree of the celestial equator from 0 to 1 to 2 to 10. We will show you the chart next year, how many degrees of the ecliptic had set during that period, and also at each time what is inclination